Good evening. Welcome to
Math for Kids number 114.
Math for Kids number 114. Okay, now we're going to get back to taking a look at
Pascal's triangle.
Pascal's triangle. Okay, you ready?
Yep.
Put this ball here. Okay, so remember how Pascal's triangle goes. It starts with a 1, and then the sides have
1.
Step closer a little bit. And then how do you get, once you put a 1 on the side, how do you get the next numbers?
You have to add the two numbers with 1, 2, 1.
Okay, so you have the two numbers above it, 2 and then a 1 on the outside. 1, 3, 3,
1.
1, 4, 6, 4, 1, 5, 10, 10, 5, 1. Okay? And this is going to keep going on forever. So we'll probably do a few more videos about this and look at some really neat patterns, because there are some really neat patterns. And we've looked at a few already. But today we're going to look at one. And let me show you what one of the other kind of fun patterns is that we'll probably do tomorrow. 1, 6, 15, 20, 15, 6, 1. If I go down any diagonal this way and add up the numbers, let's see what I get. I start with a 1. And then if I go down 2, I would get 1 plus 3, which is
4.
See a 4 anywhere? 1 plus 3 plus 6 is 10. 1 plus 3 plus 6 plus 10 is
20.
20. Isn't that interesting?
Yeah.
And it works with any row. 1 plus, or any diagonal, 1 plus 4 is?
1 plus 4 is 5.
1 plus 4 plus 5 is, 1 plus 4 plus 10 is?
It's 15.
15.
Ooh.
1 plus 1 is?
2.
2. 1 plus 1 plus 1 is?
3.
3. That's pretty neat.
Yeah.
But today we're going to do something really fun. We're just going to alternate plus minuses here. So plus, plus, minus, plus, minus, plus, plus, minus, plus, minus, plus, minus, plus, minus, plus, plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay? So we got a lot of adding up we got to do. So let's look at the rows. What is this row add up to? Remember what row number this is?
0.
That's the 0 row. So that adds up to 1 in my little plus minus thing. This is the first row, the 1 row. What does that add up to?
It's plus 1 minus 1, which is 0.
0. Good. What does the second row add up to? Why don't you write this for me?
It's plus 1. Plus 1.
Don't make those marks, please. 0, 1, 1, 0. Okay.
It's plus 1 minus 2 plus 1, which is also 0.
Okay, so write the second row and then what it adds up to.
Adds it to 0.
Okay, now do the third row.
So 1 plus 1 minus 3 plus 3 minus 1. Well, that's also 0.
Why?
Because these cancel and these cancel.
Right, because the 3's have a minus 3 and a plus 3, and the 1's have a plus 1 and a minus 1. So row 3 adds up to 0. Okay, how about row 4?
So 1 minus 4 plus 6 minus 4 plus 1 is 0.
Oh, okay. All right, so now let's kind of scratch our heads here and see if we can see a pattern.
Well, everything's adding up to 0.
Except what?
Except for number 0.
Except the first row, which only has one number in it. So what do we think this row is going to add up to?
0.
All right, let's see if it does.
So plus 1 minus 5 plus 10 minus 10 plus 5 minus 1. Everything cancels and you get a 0.
Okay, so you have a plus 10 and minus 10, minus 5 is 5. Okay, so row 5 adds up to 0. And row 6, what does row 6 add up to?
Okay, 1 minus, plus 1 minus 6 plus 5 plus 15.
Yeah.
It's hard to see.
Yeah, sorry.
Minus 20 plus 15 minus 6 plus 1. Hey, that also adds up to 0.
Okay, interesting. Now, so what do we think? Any row except for this very first row, the 0 row. is
So
gonna add
any
up-
row is going to equal 0.
Any row, when you do alternating plus minuses, we think it's going to add up to 0. Now, let's see if we can understand why that's true. Okay. So let's say we have a row here that adds up to 0. Okay. How do we make the next row? Now remember, we make the next row before the pluses and minuses are put in. So when we make the next row, it's all pluses, right? So let me erase the signs for just a second. Actually, let me just erase everything and I'll rewrite the row. So it goes 1, 6, 15, 20, 15, 6, 1. I don't think I wrote that 20 very well. Okay?
Yeah.
Now, how do I make the next row? What do I do?
You add the 2 above it.
Okay, so I start with a 1 on the outside. And then this, what is this number that fills in here?
7.
Okay, but how do I get it?
You 1 plus 6.
Okay, so this 1 has a 1 that goes there and a 1 that goes here. And the 6 comes here and also here. I don't quite have enough room to do what I want to do. Do you mind if I back up and do it with the fifth row so I have a little more room?
Okay, that's fine.
Sorry about that. Not the best planning by me, but let's see. So I'm going to start with 1, 4, 6, 4, 1. And this 1's going to come down like this. This 4 is going to come down like this. The 6 is going to come down like this. The 4 is going to come down like this. And this 1's going to come down like this. So I'm going to get a 1, 1 plus 4, 4 plus 6, 6 plus 4, 4 plus 1, and 1. Do you see that?
Yeah.
Okay, so I always add the numbers from above, except I start with this 1 on the outside, and then I add 1 plus 4 to get this number, 4 plus 6 to get this number, 6 plus 4 to get this number, 1 plus 4 to get this number, and then I take my 1 there to get that number. Okay?
Yep.
Now let's see what happens when I put in my plus and minus signs. Plus, minus, plus, minus, plus, minus. Okay?
Well, everything cancels.
Well, we know that everything cancels, but we're going to try to see why it's always going to be true. So let's take a look. This plus 1, what is this going to cancel with? What is that plus 1
It's
going to...
minus 1 on the opposite side.
Do you see anything else that this plus 1 is going to cancel with? Do you see any other minus 1s hanging around?
Well, there's a minus 1 there.
There's a minus 1 right here. And that's the same 1, right? This is a plus 1 and a minus 1. Do you see that?
Yeah.
So I alternated my signs. This arrow going this way was a plus 1, and the arrow going this way was a minus 1, so they canceled to produce a 0. Now I have this minus 4 here. Do you see anything that cancels with that minus 4?
It's plus 4.
Aha, so here the 4 had a minus when it went this way, and a plus when it went that way. So this 4 and that 4 add up to be
0.
another 0. Now let's take a look at the 6. What does the 6 get when it goes that way?
It's a plus 6.
It's a plus 6. And how about when it goes this way?
It's a negative 6.
It's a minus 6. Well, that's very interesting. So those two 6's add up to 0. Now what about the 4's? Is this a plus 4 or a minus 4 when it comes down this way?
That's a minus.
It's a minus 4. And what about when it goes this way?
It's a plus.
It's a plus 4. So these 4's add up to 0.
And then it's going to look the same for the other one.
For this 1, I got a plus 1.
And
And I got a
1.
minus 1, so I got a 0. So it's the fact that each number comes down twice from above, and one gets a plus and one gets a minus when you do the alternating signs. That's why they add up to 0. And that's also why the very first one didn't add up to 0. Because that didn't come from anywhere, right?
Yeah.
Yeah. Okay. So that's pretty fascinating. So we've looked at when you pretend these are actually numbers, like 1, 11, 121, 1331. There we got powers of 11, right?
Yeah.
We've looked at when we added the rows up directly. Add up to 1, 2, 4, 8, 16, 32. So there we got what?
The powers of 2.
There we got powers of 2. Come a little closer, please. And now we look at when you do alternating signs. And when you add up with alternating signs, what do you get?
You get 0.
You get 0.
Except for the very first one.
Except for the very first one. Isn't that amazing?
Yeah.
Just with this little idea with these numbers. So in the next couple of days, we'll look at a couple other incredibly interesting patterns in Pascal's triangle. And you know what? There are so many patterns in Pascal's triangle that people are still searching for them today.
Searching for more patterns?
Yeah, searching for more patterns. Let me show you one last one real quick. Let me grab an eraser and help you erase over there. Just erase that chart. There's one really neat thing you can do. I think I've showed you this before. If you just do, where'd my purple marker go? If you just do Pascal's triangle with zeros and ones, so we're going to just have some very simple addition rules. 0 plus 0 is going to be 0. 0 plus 1 is going to be 1. And then 1 plus 1 is going to be 0.
Pascal's triangle in binary?
It's sort of binary, but it's only one digit at a time. So it's kind of a funny rule that 1 plus 1 is 0. Mm. But all I mean is when I have two ones on top and I add them together, to do my Pascal's triangle rule, I get a 0. So, you ready? 1, 1, 1. 1, what happens when I add these two ones together?
0.
0. And I have a 1 on the outside. 1, what's 1 plus 0?
Is 1.
1. 0 plus 1 is?
1.
Then I get 1, 0, 0, 0, 1. 1, 1, 0, 0, 1, 1. 1, 0, 1, 0, 1, 0, 1. What's this row? What's this row going to be?
It's going to be a 1, 1, 1, 1, or ones.
Hey, we had another row here that was all ones too.
Looks like every 4 rows it comes.
Well, let's see. 1, 0, 0, 0, 0, 0, 0, 0, 1. We had another row that was all we had a couple rows that have had ones on the outside and all zeros in between. For example, here's one, here's one, and here's one. And notice the rows that were all ones came before those. I don't know if this one should count or not. But let's look. This is row number 0, row number 1, row number 2, row number 3, row number 4, row number 5, row number 6, row number 7, row number 8. First of all, let's look at the ones that have ones on the outside and all zeros on the inside. It's 8, 4, and 2. 2, 4, 8. Does that remind you of any pattern?
Powers of 2.
Powers of 2. So what do you think the next ones is going to have?
16.
It's going to maybe be 16, but you'd have to fill this out yourself. And look at what else. The ones that have all ones come right before that. Right before. So what do you think the next one that's going to have all ones is going to be?
It's going to be on number... It's going to be probably 15.
15, right before the next power of 2. Isn't that interesting? And then you get these interesting little upside down triangles. So I wonder if you're going to get an upside down triangle kind of like this. I know that went off screen. It goes all the way down to 15. And you have this triangle here that looks very similar to this triangle here. See 1, 1, 1, 1, 0, 1, 1, 1, 1, 0, 1. You see that pattern?
Yep.
Pretty interesting, isn't it?
Yeah.
What do you call it when you have these patterns that repeat all over the place inside of something? Do you remember what that's called?
No.
It's called a fractal. So this might start looking like a fractal.
Pascal's triangle fractal mode.
Yeah, fractal mode. Okay, so that's just some neat stuff. So you can play around with Pascal's triangle and find incredible patterns. All right, so good job today, and tomorrow we'll look at some patterns that go down the diagonals. Okay?
Yeah.
All right, good job today.